So today we are sketching polynomials. We graphed some stuff, and but when we graphed, we had specific points that we were plotting. We're still going to have some specific points here, but we had specific points, and if we wanted to graph more, we could have graphed an infinite amount of them and made the most perfect graph ever, okay? But when we're sketching and not graphing, that's because we're not going to be able to find all of the important things. Remember, we can't find the maximums and the minimums without calculus, so we're not going to know those. So, and that's fine because you don't always have to know everything, but that means our graph isn't necessarily 100% accurate, and all four of your graphs could look different, and you could still all be correct in a little bit of a way. So we'll talk about how that works. Let's go down to the bottom first. We're going to talk about end behavior again, okay, because we talked about it yesterday and the day before, and then a whole bunch of stuff before that. And today we're finally going to talk about middle behavior. End behavior is important, but we're going to talk about middle behavior as well. So, end behavior of polynomials. If I have an even degree, okay, even degree, remember that that's going to model a parabola, right? If it's a monomial function, they all look like parabolas, but these aren't going to be monomials. These are polynomials, which means the middle behavior is going to be different, but the end behavior would be the same. So if I have a positive leading coefficient, then the end behavior is up, up. That's all I care about right now. The middle is going to come somewhere else. But then what this means and what this comes from that we've already done 1,000 times, that this means as x approaches infinity, f of x approaches what? Infinity. And as x approaches negative infinity, f of x approaches infinity as well. Good. So again, the words are still important, but right now the little pictures are a little bit more important. So if it's even still and a negative leading coefficient, then the ends are still the same because it's still even, but they're going to reflect down. So this would be a down, down, which would change both of these to negative infinity. Okay. For odd degree, it's going to model a cubic. Okay, so you think about what a cubic parent function looks like. And when we have a positive leading coefficient, the end behavior will be exactly like that. So it's going to be down, up. So that means as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. Okay. Then odd degree, negative leading coefficient. Ends are opposite because it's odd, and this time it's going to be up, down instead of down, up, and then that makes this be negative infinity and then infinity. Okay, so that whole up, up, down thing that we talked about yesterday, that is a big part of what we're doing today, okay? So now I'm going to explain to you the steps of sketching, which is up at the top of this page, and just kind of stay with me what I'm talking about, and then it'll all make a little bit more sense when we actually go sketch, but I just want to talk our way through this first. Okay, so when we sketch polynomials, we're going to find the x-intercepts, or the zeros, which we are totally capable of doing. We're going to find the y-intercept, which we are totally capable of doing. Then the 3, 4, and 5 all go together. We're going to notice if the polynomial has an even or odd degree, so we look at the highest degree. Then we also have to notice the sign of the leading coefficient and determine the end behavior. So like I said, these all kind of go together here to mean this. If I have, when it says even or odd, so we have even and we have odd, right? So the even is either going to be up, up, or down, down, depending on whether it's positive or negative. And the odd is going to be either down, up, or up, down, depending on whether it's positive or negative. Okay? So that's why we care about the sign and the degree and all that stuff. It helps us get our end behavior, which is going to help us with our sketches. Then the next big part of this is to notice if there are factors with a degree higher than 1. That's not the degree of the whole function, it's the factor itself. So once we factor it, we have all our little parentheses, those are our factors. And if we have an even power, so an even power of a factor gives us a relative minimum or maximum on the x-axis. So this is what this looks like. It could be something like, they're bowling if you couldn't tell, something that comes down like this and maybe keeps going to something else, but that would be a relative minimum or a maximum on the x-axis. So that would be if I had something like x minus, or I'll say x plus 3 squared. So what happens when we're sketching is it just bounces off of the x-axis. It's a bounce. The official word is tangent. Okay, so a bounce, which means it's tangent to the axis. Then if I have an odd power greater than 1, because 1 is an odd number, so it would have to be like x minus 2 cubed, maybe. Then it has a point of inflection on the x-axis, which would look something like this, right? Which when we graph, yes, it's officially called a point of inflection, but we're also going to call this our wiggle, because that's kind of what we are doing when you're actually sketching it. It's going to bounce or it's going to wiggle. And then we draw a continuous curve. Okay? So the new parts to what we didn't already know is, well, we knew the end behavior because we talked about that yesterday, but it was really the bounce and the wiggle. And we'll look at the whole factor thing when we look at the actual problems, okay? So my guess is you probably don't have any questions because you don't really know what to ask yet. So let's do one and then we'll see if we have any questions. Okay, so flip it over. Let's look at this. All right, so this is the polynomial that they have given me. And we have these things here. Now, today's assignment is in Delta Math. Tomorrow we're going to sketch some of these in class on our own. But today's in Delta Math. In Delta Math, it does not ask you for these things. But you can't do the sketch without figuring them out. Okay, so you're going to need a piece of paper to jot that stuff down. Did you need something, hon? What are you looking for? You know what? There's some on my desk over there. So you can go behind my desk. You see them? Okay. All right, so we're going to look at the degree. Now, when we looked at the degree yesterday, things were all multiplied together. These are not multiplied together, and we don't have to multiply them together, but we need to think, if I did multiply them together, and I multiplied x times x times x, what would my degree be? 3. Yeah, it would be x cubed, so my degree is 3. Okay, that's how you can figure it out pretty easily. So end behavior. This is odd, which means the ends are opposite. This is positive. So is it down, up, or up, down? Down, up, because it looks like a cubic, right? That's my end behavior. My x-intercepts, now it says intercepts, which means I have to put them in ordered pairs, okay? My x-intercepts are -1, 0, 3, 0, and -4, 0. Okay, make sense? Then my y-intercept is when x is 0, so I got to figure that out. So y equals, so if I substitute zeros in for all those x's, I get 1 times -3 times 4. So that'll give me -12 from 0, -12. So when you're sketching these by hand, I'm going to give you blank axes like this. In Delta Math, the axes will already be there and have numbers on there. When you're going through there, I'm going to give you some other tips at the end, but just make sure, as long as you're really, really close to hitting that number, it's fine. Like it's very giving there. But we're going to be able to just label this ourselves. When I look on the x-axis, I'm only going out to -4, so I'm only going 4 away from 0 on either side. So I could probably get 5 on here. 1, 2, 3, 4, 5. Yeah, so you just do your best to do them evenly. Don't get out a ruler. This is sketching. We just want to look at, try. And then I'm not putting the little hash marks on the y-axis because I have multiple things to do on x. I only have one thing to do on y. I don't really care what the scale is, so I can just go, okay, right there, that's negative 12. So that's the only one I have to label with a number because it's not marked out. Does that make sense to you? I don't have to like put here 1, 2, 3, 4. You don't have to put the numbers on there. So then I'm going to plot these points. I'm going to plot negative 1, 0. I'm going to plot 3, 0. I'm going to plot negative 4, 0, and then this negative 12, which I kind of already have there. Now I'm going to sketch this thing in. I know where to start because my end behavior is down up. So I'm down here. The only time you are allowed to cross the x-axis is at one of these points that you plotted. Okay, so I can't, well, let me kind of show you and then do it, and then I'll have you do it. So I know my end behavior is down up. So I know I'm going to start down here. I'm going to go up through this one, back down through this one. I have to hit my y-intercept and go back up. I have no idea how far to go up here because remember my maximum is not something I can find, and that's okay. Also, I don't know if my minimum is at the y-intercept on this side of it or on this side of it. So it's fine, whatever works and however you get there. So I'm going to sketch this in, come down here, and back up. So it would look something like that. And if yours isn't exactly like mine, that's okay. And remember, nothing is pointy, everything is curvy. Okay? So now I'm going to draw something extra on here that is wrong, so don't do it. Let's say that we messed up on our y-intercept and we got a positive 12. Okay? So I got a positive 12, which means I don't have this number. So I'm going to start to draw. I'm going to go, all right, so I'm supposed to come up through here and then back down through here, and how the heck am I supposed to hit 12? So what some people will do will go back up like this to come back down through there, and that's like totally wrong because I can't actually cross right there. You with me on that? So that tells me that when I can't get there, that something is wrong. Maybe my end behavior is wrong, because if I started up here, I'd be okay. So maybe I messed up on my end behavior, or maybe I messed up on my y-intercept. But if things don't connect like you think they should, something on your graph is wrong, because every time it'll flow real nicely. Okay, does that make sense? All right, so this is when we talk about our factors. These, oh my gosh. These are my 3 factors, right? So when I look at number 2, I also have 3 factors. Okay? So let's go ahead and get through some of that, and then we'll go back and talk about that squared. The degree here, what do you think the degree would be on this one? 4, good, because I'd square this and get x squared, multiply by another one, multiply by another one, so I'd have 4 x's multiplied together. So my degree is 4. So my end behavior, what happened to my 3 up here? My end behavior, since it's even, is the same. It's either up, up, or down, down. What is it? Up, up, right? Because it's even. So up, up. My x-intercepts, this guy is important. We can't forget about him. He gives us 0, 0. Then I get 2, 0. Then I get 6, 0. Okay. My y-intercept, y equals 0 times negative 2 squared times negative 6. Does anything really matter after I write 0? No. And so I really didn't even have to write it down, because if 0, 0 is one of your x-intercepts, then it is your y-intercept, and you really don't have to do anything. Just wanted to kind of point that out. Now, one of the things it said on there is if we have a factor, so I have 3 factors there. If I have a factor whose degree is greater than 1, and I do, it's right here, right? If I have a factor that has a degree greater than 1, then it's either going to be a bounce or a wiggle, right? If it's even, it bounces. Okay, odd, it wiggles, and you can remember because that wiggles a point of inflection, and x cubed is the one that has the point of inflection. So the odds will have the point of inflection, the evens have the bounce. So I'm going to make a little note right here that right here is where I need to bounce, so I don't forget. And sometimes I do that and I still do it at the wrong place or still forget. And students do that too. So don't do that. Don't be that person. Don't be me. So I'm going out to 6. So I'll go just see if I can get 6 on there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. My y-intercept is 0, 0, so I don't have to worry about doing anything on that. I'm going to plot my points. I have 0, 0, 2, 0, and 6, 0. Okay, my end behavior is up, up. So I'm going to start up here. Now I'm supposed to bounce at 2, which is right there. So I'm going to start up here. I'm going to come down. I'm going to bounce, come back down, and then back up like this. And it will look something like that. But again, I have no idea how far down the minimums really go. Be careful not to do this type of thing, because remember, there's nothing that's pointy. It should have to come up and like hit a minimum like in a curve. And that, you know, do your best. Okay. What questions do you have? Seem easy enough? Kind of cool. All right. So see what you can fill out on number 3 for this part. I'm going to give you a minute to do that. Okay, so that's what I got on this stuff here. We've got the degree is 5. Do we all agree with that? Yes? Okay. Then in behavior, since that was negative, it'll be up, down. We all good with that? Yes? Okay. My x-intercepts and then my y-intercept, which is where the biggest mistakes come in because that's where you have to do some arithmetic. All right? And once I got here to multiply these, I did 4 times 20 is 80. 4 times 7 is 28 and added them together and got 108. That's how I did it in my head. Okay. All right, so if we got all that, do I have any bounces or wiggles anywhere? What do you think? Yes, because this cubed, I got a wiggle, right? I got a wiggle right here. So I got a wiggle, so I'm going to make sure I do that. So I'm going out to 4 is the farthest I go. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That was not very evenly spaced at all, but whatever. I like to try and get one more if I can, if it doesn't make it too small, just because it kind of gives you a little bit, you know, whatever. I didn't worry about that when it was 6 because it's fine either way. Okay, so I've got 3, 0, put that there. -4, 0, -1, 0, and a positive 108. then I'm going to remind myself as I go through this that I am supposed to wiggle at 3, okay, because you got to make sure it's in the right spot as well. So my end behavior is up, down. So I start up. I kind of do a dry run first. I start up, come down through here. I'm going to go up through. I'm going to hit 108, and then I'm going to wiggle right there. So I think everything looks okay. So I come here, I go up, and then I have a point of inflection right there. Looks something like that. If you have issues getting to that point of inflection and like the angle you're coming at, you just feel like it isn't being like you want it to be, and you're not sure that I can tell what it is, do your best, and then you can write a little arrow with like POI right there. This is a point of inflection. Kind of let me know. That's fine. Okay. What questions do you have? Anything? All right. So you fill out the stuff on number 4. We'll check on that, and then I'll let you graph that one on your own. Do I have any bounces or wiggles? I got them both, right? So at -3, what's happening here? Wiggle. And at 3, that is a bounce. So I'm going to do both. So we can get 1, 2, 3, 4, 1, 2, 3, 4, and 243 is just up there somewhere. This is 243, and I have a point here, and I have a point here. And so I'm going to wiggle first, and then I bounce. See if you can get this sketched in, and then I'll sketch it. Remember, look at your end behavior so you know where to start. Then always double check yourself at the end that your end behavior that you wrote down is actually what ended up happening, that you agreed with yourself, right? So I had my point of inflection here, and then I was tangent there, down, up. That's what we said from the beginning. So we're good. Okay. What questions do you have? We good? All right.